Good morning to all. In the last class, I was telling you about ozone, the uses of ozone. See, ozone is used as a germicide, as a disinfectant, for the sterilization of water, to locate the position of double bond. You know, you have studied in your first PUC how to locate the position of double bond in an alkene. Suppose there is a long chain of carbon atoms like this. If the double bond is located here, then it will be CH2, double bond CH, CH2, CH2, CH3. It is pent 1-ene, isn't it? It is pentene. If you make it to react with ozone, what happens? Ozone attacks the site of double bond. And this double bond is broken to have an unstable compound with this formula called ozonide. It is pentene ozonide. When this is treated with water, what happens? This breaks. This oxygen combines with water to form H2O2. Then what is the product formed? CH2O. CH2O is nothing but HCHO. That is methanol. Methanol or formaldehyde. And this one is CH3, CH2, CH2, CHO. That is butanol. CH3, CH2, CH2, CHO. Butanol. From the products formed by ozonolysis followed by hydrolysis, we can predict that the double bond is present between first and second carbon atom. If the double bond were here on the second carbon atom, if the double bond were here, for example, if this is single bond and this is double bond, ozone attacks here. And what unstable ozonide you are getting? O, like this. And here the bond is broken. And what you get is CH3CHO. That is ethanol. And this one CH3CH2CHO. That is propanol. So you get ethanol and propanol. From the products form, that is ethanol and propanol, you will come to know that the double bond is between second and third carbon atom. Like this, the position of the double bond in an alkene can be located by using ozone. And this reaction of alkene with ozone to form the respective ozonide is called ozonolysis. Ozonolysis. And now we'll study about sulfur. So far, we were dealing with oxygen and its compounds. Sulfur. As you know, sulfur is a solid non-metal. It is generally octaatomic. That is, it exists as S8. Its atomicity is 8. Idra atomicity estada 8 ada. Its atomicity is 8. Now, can you hear?
Yes, sir.
Okay. Sulfur has many allotropes. Sulfur is a yellow colored crystalline solid. Yellow colored solid it is. It is odorless. having no smell, and the different allotropes of sulfur are monoclinic sulfur, rhombic sulfur, milk of sulfur, prismatic sulfur. These are the different allotropes of sulfur. Rhombic sulfur is often called alpha sulfur. You usually come across these two sulfurs, rhombic and monoclinic sulfur. Milk of sulfur, ಆಮೇಲೆ prismatic sulfur ಅಂತದ. ಇದಕ್ಕೆ beta sulfur ಅಂತಾರೆ. Beta sulfur. All these exist as S8. ಇವೆಲ್ಲನೂ S8 ಅಂತಾನೆ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಾವ. ಸೊ ಇವನ್ನ ಬರ್ಕೊಂಡಿರಲ್ಲ allotropes of sulfur. Sulfur the allotropes, monoclinic sulfur, rhombic sulfur, milk of sulfur, ಆಮೇಲೆ prismatic sulfur. Important ಅಂದ್ರೆ ಇವೆ monoclinic and rhombic sulfur. All the other types of sulfur are gradually converted into rhombic sulfur only. ಎಲ್ಲ ಟೈಪ್ ಆಫ್ allotropes ಸ್ಲೋಲಿ ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾವು, rhombic sulfur ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾವ. Rhombic sulfur is insoluble in water, insoluble in alcohol, insoluble in benzene, but it is soluble in carbon disulfide. Carbon disulfide has the formula CS2. Carbon disulfide nolage karagtade idu, but it is insoluble in water, alcohol and benzene. It has a structure like this. ಇದರ ಸ್ಟ್ರಕ್ಚರ್ ಹೇಗಿರ್ತದೆ ನೋಡ್ರಿ, ನಾನು ಬರೀತೀನಿ, ಐಡಿಯಾ ಬರ್ತದನ ಯಾವ ಟೈಪ್ ಸ್ಟ್ರಕ್ಚರ್ ಅನಿಸ್ತದೆ. It has a structure like this. Every corner is sulfur. Yes, how many sulfur atoms are there? ಎಷ್ಟು sulfur ಆಗ್ತಾವಿಲ್ಲ?
8.
If I consider this
Eight
is
sulfur.
the first 1, 2, 3, 4, 5, 6, 7, 8. Not that it is the first carbon. I mean, it is not the first S. Anyone can be first. Okay, it has a crown shape. Crown, kirita irutadalla, crown shape. Okay, sulfur S8 has a crown shape with a bond angle of 107 degree. All these bond angles are 107 degree. This is 107, 107, 107, 107 ಎಲ್ಲ 107 degree bond angle irtav. And the bond length is 204 picometer. All these bond lengths are 204 picometer. This is 204, 204, 204, 204. Just mention it. Note ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು. S8 has a crown shaped structure making an angle of 107 degree with a bond length of 204 picometer. So S8 ಗೆ ಯಾವ ಸ್ಟ್ರಕ್ಚರ್ ಇರ್ತದೆ? ಕ್ರೌನ್ ಶೇಪ್ಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಇರ್ತದೆ. ಬಾಂಡ್ ಲೆಂತ್ ಎಲ್ಲ 204 picometer ಇರ್ತಾವ. ನೀವು ಯಾವುದೋ ಒಂದು ವೈರ್ ತಗೊಂಡು ಆ ಥರ ಮಾಡ್ಬೋದು. ಒಂದು ಯಾವುದೋ ಕಾಪರ್ ಅಲ್ಯೂಮಿನಿಯಂ ವೈರ್ ತಗೊಂಡು ಹೀಗೆ ಕ್ರೌನ್ ಶೇಪ್ ಮಾಡ್ಬೋದು, ಮಾಡಿ ನೋಡ್ಬೋದು. monoclinic sulfur sometimes exists as S6 also. Rhombic sulfur exists as S8. Monoclinic sulfur, that is beta sulfur, exists as S6 also. Sulfur almost 99% is S8. To some extent it exists as S6 and S2 also. ಇದು S6 ಮತ್ತು S2 ಅಂತೂ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತದೆ. ಜನರಲಿ ಏನ್ ಗೊತ್ತಿರಬೇಕು, S8 ಇರ್ತದ, ಕ್ರೌನ್ ಶೇಪ್ ಇರ್ತದ, ಇದು ಬಾಂಡ್ ಆಂಗಲ್ ಬಾಂಡ್ ಲೆಂತ್ ಗೊತ್ತಿರಬೇಕು. In a very exceptional case, the other allotrope of sulfur, that is monoclinic sulfur, can exist as S6. And this S6 has this structure, E-type structure ಇರ್ತದೆ. One, 2, 3, 4, 5, 6. It has a chair-like structure. Chair, kursi irtado, a type structure irtado. Okay, chair-like structure with a bond angle of 102 degree. Bond angle 102.2 degree irtado. All these angles, here it is 102.2, here it is 102.2. On a two-dimensional board, we can't draw it properly, but when you make a model of it, I told you just now, you take an aluminum wire and try to construct it like this. You will have the idea. ನೀವೇ ಮಾಡಿ ನೋಡೋದು. ಒಂದು ಅಲ್ಯೂಮಿನಿಯಂ ವೈರ್ ಬಿತ್ತಿರ್ತಾವಲ್ಲ, ಅಲ್ಯೂಮಿನಿಯಂ ತಂತಿ ಅಥವಾ ಐರನ್ದು ಇರ್ತಾವ, ಈ ಬಾರ್ ಬೆಂಡಿಂಗ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಕಟ್ ಮಾಡಿ ಒಗದಿರ್ತಾರಲ್ಲ, ಅವನ್ ತಗೊಂಡು ಕ್ರೌನ್ ಶೇಪ್ ಮಾಡಿ ನೋಡ್ರಿ, ಆಮೇಲೆ ಈ ಟೈಪ್ ಚೇರ್ ಶೇಪ್ ಮಾಡಿ ನೋಡ್ರಿ. ಅಂಡ್ ಬಾಂಡ್ ಲೆಂತ್ is about 207 picometer. Bond length is about 207 picometer. S2 is formed when S8, that is rhombic sulfur, is heated to about 1000 Kelvin. S2 ಅಂತ ಏನದಲ್ಲ, ಇದು ಯಾವಾಗ ಫಾರ್ಮೇಶನ್ ಆಗ್ತದಂದ್ರ ರಾಂಬಿಕ್ ಸಲ್ಫರ್ ಅನ್ನ 1000 ಕೆಲ್ವಿನ್ ಡಿಗ್ರೀಸ್ 1000 ಕೆಲ್ವಿನ್ ವರೆಗೆ ಹೀಟ್ ಮಾಡಿದಾಗ S2 ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ. S2 is like O2. S2 ಹೆಂಗಿರ್ತದ, ಆಕ್ಸಿಜನ್ ಇದ್ದಂಗೆ ಇರ್ತದ, ಹೆಂಗ O2 ಅಂತ ಇರ್ತದಲ್ಲ. Sulfur belongs to oxygen family, isn't it? These are called chalcogens. S2 ಅಂತನೂ ಇರ್ತದೆ ಇದು. And like oxygen, it is also paramagnetic in nature. S2 is paramagnetic in nature. Why it is paramagnetic in nature can be explained based on molecular orbital theory, which you have come across. In case of O2, it contains 2 unpaired electrons in pi star 2px and pi star 2py. This also has 2 unpaired electrons in pi star 3px and pi star 3py. Isn't it? The next orbit. The configuration ಏನಿರ್ತದೆ 3s2 3p4 ಇರ್ತದೆ. ಆಕ್ಸಿಜನ್ ಅದು 2s2 2p4. ಹೌದಾ? ಸೊ ಇಲ್ಲೇ 2 unpaired electrons ಇರ್ತವೆ S2 ದೊಳಗೆ. And that is why it is paramagnetic in nature. S2 is paramagnetic in nature. So this is the idea regarding sulfur. So ಏನ್ ನೆನ್ಪಿಟ್ಕೋಬೇಕಿಲ್ಲ, ಕನ್ಕ್ಲೂಷನ್ ಮಾಡೋದಾದ್ರೆ, sulfur is a yellow colored crystalline solid and it is odorless. So when it exists as S8, it has a crown shape with a bond angle of 107 degree and bond length of 204 picometer. It is soluble in carbon disulfide but insoluble in water, alcohol and benzene. Rhombic sulfur. The other allotropes like monoclinic sulfur, milk of sulfur, which is also called plastic sulfur, and prismatic sulfur, are gradually converted into rhombic sulfur only. Sulfur, particularly monoclinic sulfur, which is called beta sulfur, can exist as S6. And this S6 has a chair-like structure. Chair-like structure with a bond angle of 102 degree and a bond length of 207 picometer. And when S8, that is rhombic sulfur, is heated to about 1000 Kelvin, it is converted into S2. And this S2 is paramagnetic in nature. Paramagnetic means it is attracted, weakly attracted by the magnetic field due to the presence of two unpaired electrons. That's all about sulfur. And now we'll study about compounds of sulfur. The important compounds of sulfur are sulfur dioxide, sulfur trioxide, and sulfuric acid and oxo acids of sulfur. Important compounds, so mainly other biggest study oxo acids of sulfur. Just like in nitrogen and phosphorus, you come across oxo acids, no? H3PO2, H3PO3, H3PO4, H4P2O7, H4P2O6, H4P2O5, HPO3 something. Hang sulfur kuno ಕೆಲವೊಂದು oxo acids ಅವ, mainly two, H2SO4 and H2SO3. And there is one more important acid, H4-2S2O7. There is H4S2O5 also. Firstly, we'll study about SO2. What is SO2? Sulfur dioxide. SO2 is sulfur dioxide. So what is SO2? How it is prepared? Heng prepare ಮಾಡ್ತಾರೆ ಇದನ್ನ? SO2 ನ ಹೇಗೆ prepare ಮಾಡ್ತಾರೆ ನೋಡೋಣ. It is prepared simply by burning sulfur in air. When sulfur is burnt in air, sulfur dioxide is formed. But in large scale, in industrial scale, it is obtained by burning FeS2. FeS2 is called iron pyrite. FeS2 ಗೆ ಏನಂತಾರೆ? Iron pyrites ಅಂತ. It is an ore of iron from which it can be extracted. You might have come across this in topic General Principles of Isolation of Elements. See, when iron pyrites are burnt, it is converted into Fe2O3 and SO2. And how you are going to balance the equation? As there is Fe2 here, I take 2 FeS. As there are 4 sulfur here, I write 4 SO2. But see the oxygens, here there is O3 and here there is O2. With odd number of oxygen, we can't balance it. So we'll have to double this. Oxygen ಇದು ಆಡು ಈ ಕಡೆ ಇವನ್ ಇತ್ತ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ ಬರಂಗಿಲ್ಲ, ಅದಕ್ಕೆ ಡಬಲ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು. When this becomes 2 Fe2O3, this should be made 4 FeS2. Isn't it? 2 Fe2 ada, 4 Fe ada. And how many sulfur are there? 8. So this should be 8 SO2. This is 8 SO2. So iron, sulfur are balanced. Count the oxygen
11 O2
and then balance it. Good.
11O2.
8 to the 16, 16 plus 6, 22. So it must be 11O2. Okay. So this is how SO2 is produced in large scale, in industrial scale. You come across this reaction again in the manufacture of sulfuric acid. In order to manufacture sulfuric acid, SO2 is required, and this is how it is produced in the first step. Sulfur dioxide is produced either by burning sulfur in air or iron pyrites in air. But in laboratory, this is not the way how we prepare SO2 in laboratory. In laboratory, it can be prepared from sulfites like Na2SO3. Na2SO3 is sodium sulfite. Na2SO4, however, is sodium sulfate. Sulfate andre SO4 iruttade, sulfite andre SO3 iruttade. When sodium sulfite, it is a crystalline colorless solid, is made to react with HCl, hydrochloric acid. Then what happens is formation of NaCl, H2O and SO2. In order to balance the equation, as there are 2 Na here, I take 2 NaCl. There are 2 chlorine here, so 2 HCl. Now count the hydrogens and oxygen. There are 2 hydrogen and there are 2 here in H2O. 1 sulfur is there, and oxygens there are 3 here, so 1 in water and 2 in SO2. It can be very easily prepared. Take sodium sulfite in a test tube and add hydrochloric acid. There is evolution of SO2. You don't have to heat even. Heat ಮಾಡಬೇಕಾಗಿಲ್ಲ. Sodium sulfite ತಗೊಂಡು hydrochloric acid ಹಾಕ್ಬಿಟ್ರೆ sulfur dioxide gas liberate ಆಗ್ತದೆ. You can even prepare it by the reaction of NaHSO3 with HCl. Just tell me, what is NaHSO3? NaHS, sodium bisulfite. Sodium hydrogen sulfite antar, sodium bisulfite antar. It's very similar to Na2CO3 and NaHCO3. You can recall them. Na2CO3 ಅಂದ್ರೆ sodium carbonate, NaHCO3 ಅಂದ್ರೆ sodium bicarbonate. ಹಂಗೆ ಇದು sodium sulfite, ಇದು sodium bisulfite. When this reacts with HCl, again the same products, that is NaCl plus H2O plus SO2 are formed. And it is already balanced. 1 NaCl is there. H and 1 oxygen from this is H2O. When you remove 1 oxygen, there remains SO2. Okay. You can note these equations. How SO2 can be prepared. SO2 can be prepared by burning sulfur in air. In large scale, in industrial scale, it is prepared by burning iron pyrites in air. We call it as roasting of hematite. Howda? Roasting ಮಾಡ್ತೀವಿ, roasting of iron pyrite. Roasting of iron pyrite. It can be prepared in laboratory by the action of hydrochloric acid on sodium sulfite and bisulfite. Okay, write the equations. Well, moving on to the properties. ಬರ್ಕೊಂಡ್ರಿ equations ಅನ್ನ?
Yes, sir.
Good. And now we'll study about the properties of sulfur dioxide. SO2 is a colorless gas with a pungent and suffocating odor. Sulfur dioxide colorless irtade, pungent and suffocating odor irtade. ನೆನಪದ ಹೇಳಿದೀನಿ ನಿಮಗೆ, suffocating ಅಂದ್ರೆ causes problems with the respiration. Suffocation ಅಂತಂದ್ರೆ ನಿಮ್ ಬಿಜಾಪುರ ಭಾಷೆದಾಗ ಏನಂತೀರಿ? ಉಸಿರುಗಟ್ಟದಂಗ ಆಗೋದು. ಸಫೋಕೇಶನ್ ಆಕತೈತಿ, ಸಫಿಸಿಯಂಟ್ ಗಾಳಿ ಆಕ್ಸಿಜನ್ ಸಿಗಲಿಲ್ಲ ಅಂದ್ರೆ ಸಫೋಕೇಶನ್ ಆಗ್ಲಿಕತ್ತ, ಉಸಿರುಗಟ್ಟದಂಗ ಆಗ್ಲಿಕತ್ತೈತಿ ಅಂತ. ಹಂಗೆ ಇದಕ್ಕೆ ಪಂಜೆಂಟ್ ಸ್ಮೆಲ್ ಇರ್ತದೆ, ಸಫೋಕೇಟಿಂಗ್ ಅದೈತಿ ಗ್ಯಾಸ್ ಅದೇ. ಓಕೆ, ಇಟ್ ಈಸ್ ಹೈಲಿ soluble in water, and when it dissolves in water it reacts with it. SO2 dissolves in water to form H2SO3. So SO2 is acidic in nature. It is an acidic oxide because it reacts with water to form acid. It reacts with water to form sulfurous acid. H2SO3 ke nantara sulfurous acid. In order to know whether a gas is acidic or not, what we can do is take a moist litmus paper. Moist means first we have to dip it in water and then hold it in gas. Okay? Then it turns red. If you hold a dry litmus paper, it may not turn, because in a dry condition SO2 does not, it's not an acid. When it comes in contact with water, it forms acid. That's why it turns moist blue litmus paper red. And it can react with bases. SO2 can react with bases like NaOH, KOH, or CaOH twice to form the respective sulfides. When SO2 reacts with NaOH, as I told, SO2 is acidic in nature. NaOH, you know, that is a base. They react to form NaHSO3, that is sodium bisulfite. And when the same SO2 reacts with 2 NaOH, it forms Na2SO3 plus H2O. See? Na2SO2 ಅದ, ಇದ್ರೊಳಗಿಂದ ಒಂದು ಆಕ್ಸಿಜನ್ ತಗೊಳ್ಳೋದು, ಎರಡು ಅದಾವಿಲ್ಲ, 2 NaOH ಐತಿಲ್ಲ, ಒಂದು ಆಕ್ಸಿಜನ್ ತಗೊಂಡು ಇದ್ರ ಜೊತೆ ಕಂಬೈನ್ ಮಾಡಿ SO3 ಆಯ್ತು. ಆಮೇಲೆ ಏನು ಉಳಿತು, 2 hydrogens and 1 oxygen is H2O. So SO2 is neutralized by NaOH to form sodium bisulfite and sodium sulfite. Okay? It shows that SO2 is acidic in nature. Sulfur dioxide is acidic in nature. ಬರ್ಕೊಂಡಿರಿ ಇವನ್ನ. ಹಾಗೆ ಒಂದ್ಸಾರಿ ಕೇಳಬೇಕು. ಹೇಳೋ ಮುಂದೆ ಫಸ್ಟ್ಗೆನೆ ಬೋರ್ಡ್ ಮೇಲೆ ಬರೆಯಕತ್ತಿದ ಕೂಡ ಬರ್ಕೋಬೇಡ್ರಿ. ಒಂದ್ಸಲ ನಾನು ಇಕ್ವೇಶನ್ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತೀನಿ, ಅವಾಗ ಬರೀಬೇಕು. So SO2 reacts with water to form sulfurous acid. SO2 is acidic in nature because it reacts with NaOH to form sodium bisulfite and sulfite. These are salts. When you salt, salt, acid and base react to form this compound. Now, some more reactions. Addition reactions of SO2. What are addition reactions? Addition reactions ಅಂದ್ರೆ ಏನು? ಫಸ್ಟ್ ಇಯರ್ ಒಳಗೆ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಒಳಗೆ ನಿಮಗೆ 3 ಟೈಪ್ ರಿಯಾಕ್ಷನ್ಸ್ ಬಂದಿರ್ತಾವ. ಆರ್ಗ್ಯಾನಿಕ್ ರಿಯಾಕ್ಷನ್ಸ್ ಒಳಗೆ ಯೂಶುವಲಿ ಯಾವ 3 ಟೈಪ್ ರಿಯಾಕ್ಷನ್? ಎಡಿಷನ್ ರಿಯಾಕ್ಷನ್ಸ್, elimination reaction and another substitution reaction. Addition reaction andra you add something without removing anything from that molecule. Elimination reaction means removal of something from that molecule without adding anything. Whereas substitution means replacement of an atom or group by another atom or group. What is elimination? Let me tell. C2H5Br ಅದ. ಇದ್ರೊಳಗಿಂದ ಒಂದು HBr ತೆಗಿತೀನಿ ನಾನು. HBr ತೆಗೆದ್ರೆ ಏನು ಉಳಿತದೆ? C2H4. We call it as elimination because we remove HBr from this. How it is removed? By reaction with alcoholic KOH. This reaction is called dehydrohallucination, in particular in the preparation of alkenes. You had come across this. Idu enu elimination reaction. ಈಗ substitution reaction ಅಂದ್ರೆ substitution reaction ಹೇಗೆ? ಈಗ methane ಅದ. When I make methane to react with chlorine, what happens? One hydrogen is removed and chlorine is added. So you get CH3Cl. So what is this reaction? Substitution, because an atom H is removed and chlorine is added. This is substitution. And what is addition? Idu substitution. Idu substitute antaralla. ಈಗ ನೀವು ಕ್ರಿಕೆಟ್ ಆಟ ಆಡಬೇಕಾದಾಗ ಯಾರೋ ಒಬ್ರು ಇಂಜುರಿ ಆಗ್ತದೆ ಒಬ್ಬ ಪ್ಲೇಯರ್ಗೆ, ಅವಾಗ ಏನಾಗ್ತದೆ? he is replaced by some other player and he is called a substitute. ಹಂಗಿಲ್ಲೂ ಕೂಡ substitution ಅಂದ್ರೆ replacement of an atom or group by another atom or group. ಈಗ addition ಅಂದ್ರೆ organic reaction ತಗೊಂಡು ಹೇಳೋದಾದ್ರೆ ಇದು CH2 double bond CH2 ಅದ. When I make it to react with H2 in presence of nickel catalyst, what happens? One H is added to this, another H is added to this, and it becomes CH3 single bond CH3. We removed nothing from this molecule. ಇದರಿಂದ ಏನನ್ನೂ ರಿಮೂವ್ ಮಾಡಲಿಲ್ಲ, ಬರೀ ಆಡ್ ಮಾಡಿದ್ವಿ. ಇದಕ್ಕೆ ನಂತರ addition reaction. You got the idea? Addition, elimination, and substitution reactions. Now, addition reactions of sulfur dioxide I was telling. Addition reactions. SO2 can react with chlorine in presence of a little catalyst, charcoal catalyst. ಒಂದು ಸ್ವಲ್ಪ ಚಾರ್ಕೋಲ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಆಗಿ ಹಾಕಿದ್ರೆ SO2 Cl2 ರಿಯಾಕ್ಟ್ ಆಗಿ SO2 Cl2 ಅಂತ ಬರ್ತದೆ. So it is simply combination of these two and it is addition reaction. So we are going to explain this reaction. Sulfur dioxide reacts with chlorine in presence of an activated charcoal catalyst to form, what is this? SO2 Cl2 again antar.
Sulfuryl chloride.
Good. It is called sulfuryl chloride. There is one more, SOCl2. There's a chance of getting confusion. So what is this? SOCl2. SOCl2 again antar. Thionyl chloride antar. This is called thionyl chloride. This, however, is sulfuryl chloride. Now, SO2 can react with O2 in presence of platinum or vanadium pentoxide catalyst to form SO3. So, what have you done? You added an oxygen to this. ಇದಕ್ಕೊಂದು ಆಕ್ಸಿಜನ್ ಆಡ್ ಮಾಡಿ SO2 ಹೋಗಿ ಏನಾಗದ SO3 ಆಗದ. as it takes only one oxygen. ಇದು ಒಂದೇ ಆಕ್ಸಿಜನ್ ತಗೋತದೆ. ಮತ್ತೆ ಎರಡು ಆಕ್ಸಿಜನ್ ತಗೋಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? 2SO2. This is 2SO3. This can be called as oxidation reaction also. ಇದಕ್ಕೆ oxidation ಅನ್ಬೋದು because there is addition of oxygen. Okay, so these two are addition reactions of sulfur dioxide. You come across again this in the manufacture of sulfuric acid is a very important step in the manufacture of sulfuric acid. Conversion of sulfur dioxide to trioxide. So these are addition reactions of sulfur dioxide. Note it down. Sulfur dioxide reacts with chlorine in presence of charcoal to form sulfuryl chloride. Sulfur dioxide reacts with oxygen in presence of platinum or vanadium pentoxide catalyst to form sulfur trioxide. These are addition reactions of sulfur dioxide. And now, reducing property. Reducing property means SO2 can act as a reducing agent. What do you mean by a reducing agent? Reducing agent ಅಂದ್ರೆ ಏನು? ಕೇಳಿಸ್ಲಿಕ್ಕತ್ತದ? Reducing property of sulfur dioxide. Okay. Reducing agent ಅಂದ್ರೆ ಏನು ಅಂತ ಹೇಳೋದಕ್ಕೆ ನಿಮಗೆ ಒಂಥರ ಡೈಲೆಮಾದಾಗ ಬರ್ತೀರಿ. ಯಾಕಂದ್ರೆ ಬಹಳಷ್ಟು ಡೆಫಿನಿಷನ್ಸ್ ಅವ. Reducing agent ಅಂದ್ರೆ ಏನು? The one which helps for reduction. Reduction ಆಗ್ಲಿಕ್ಕೆ help ಮಾಡೋದು. Reducing agent is often called reductant. Their opposite ಯಾವುದು? Oxidizing agent, the one which helps for oxidation. Reducing agent means it must help for reduction by undergoing oxidation itself. Reducing agent ಅಂದ್ರೆ ಯಾವುದಾದ್ರೂ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನ ರಿಡಕ್ಷನ್ ಆಗ್ಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡೋದು. ರೆಡ್ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡಬೇಕಾದ್ರೆ ತನ್ನಷ್ಟು ತಾನೇ ಏನಾಗಬೇಕದು? ಆಕ್ಸಿಡೈಸ್ ಆಗ್ಬೇಕು. ಇಟ್ ಹ್ಯಾಸ್ ಟು ಅಂಡರ್ಗೋ ಆಕ್ಸಿಡೇಷನ್ in order to act as reducing agent. Well, sulfur dioxide is a reducing agent. How sulfur dioxide is a reducing agent? We can say that SO2 can take oxygen and undergo oxidation to SO3. Just now it come across, I told that it is oxidation reaction. What is this? Oxygen in square bracket. ಏನಂತಾರೆ ಇದಕ್ಕೆ?
Nascent oxygen.
Nascent oxygen means just born, just produced. Whenever it is required, it should be produced. This reaction shows that SO2 undergoes oxidation. It undergoes oxidation means it acts as reducing agent. ಆಮೇಲೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ನೊಳಗೆ ಏನ್ ಹೇಳ್ತೀವಿ? ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್. ಈ ಕಡೆ ಇರ್ತದೆ ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋಣ. ಎಕ್ಸಾಂಪಲ್ FeCl3. What do you mean by FeCl3? FeCl3 ಅಂದ್ರೆ ಏನು? ಗೊತ್ತಿಲ್ಲ. FeCl3 ಅಂದ್ರೆ ಏನು ಗೊತ್ತಿಲ್ಲ? ಫೆರಿಕ್ ಕ್ಲೋರೈಡ್. FeCl3 ಅಂದ್ರೆ ಫೆರಿಕ್ ಕ್ಲೋರೈಡ್, because iron has valency +3 here. You take the solution of ferric chloride in water, add water to it, it forms a solution. It is a reddish brown colored solution, ferric chloride. Now pass sulfur dioxide into it. it is converted into FeCl2. Yes, what is FeCl2?
Ferrous chloride.
Ferrous chloride. Okay, so ferric chloride, in which oxidation number of iron is +3, is converted to ferrous chloride. Ferric chloride hogi ferrous chloride ಆಗ್ತದೆ. So +3 to +2. +3 ಹೋಗಿ +2 ಆಗೋದಂದ್ರೆ ಏನಿದು? ರಿಡಕ್ಷನ್. ರಿಡಕ್ಷನ್ ಅಂದ್ರೆ ಡಿಕ್ರೀಸ್ ಇನ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್. ಈಗ 3 +3 ಚಾರ್ಜ್ ಇರ್ತಾವ. 3 +3 ಹೋಗಿ +2 ಆಗ್ಬೇಕು. ಎರಡೇ ಆಗ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? 3 +3 ಅದಾವ, ಎರಡೇ ಆಗ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತಂದ್ರೆ ಕೆಲವ್ರು ಹೇಳ್ಬೋದು ಒಂದ್ ಅಳಕಿಸ್ಬಿಡ್ಬೇಕು. ಹಾಕ್ಸ್ಬಿಡೋದಂದ್ರೆ ಇಲ್ಲಿ ಕೆಮಿಕಲಿ ನಾವ್ ಹೆಂಗ್ ಹೇಳ್ಬೇಕಂದ್ರೆ ಯು ಆಡ್ ಅನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟು ದಿಸ್. ಒಂದ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಿಬಿಟ್ರೆ ಏನಾಗ್ತದೆ? ಇಟ್ ಗೆಟ್ಸ್ ನ್ಯೂಟ್ರಲೈಸ್ಡ್. ದ ಚಾರ್ಜ್ ಗೆಟ್ಸ್ ನ್ಯೂಟ್ರಲೈಸ್ಡ್ ಅಂಡ್ ಇಟ್ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಟು +2. And what is this gain of electron? Decrease in oxidation number is reduction. This undergoes reduction. And which one is the reducing agent here? SO2. And SO2 here in this reaction is converted into H2SO4. And you get HCl also. In order to balance this equation, ಇದು balance ಮಾಡ್ಲಿಕ್ಕೆ I take 2 FeCl3 and here 2 FeCl2. The chlorine 2 3s are 6 chlorine here, and here 2 2s are 4. So I make it 2 HCl. So chlorine are balanced, 6 both sides. Okay, hydrogens. Here there are 2 and here there are 2. So I take 2H2O. Hydrogens are balanced. What about the sulfur and oxygen? 1 sulfur. Here also there is 1 sulfur. Oxygen 2 plus 2 4, and it is SO4. H2SO4. What is the oxidation number of sulfur in SO2? Sulfur the oxidation number ಎಷ್ಟಿರ್ತದೆ SO2 ದೊಳಗೆ?
4 sir.
+4 ಇರ್ತದೆ. Here it is +4. And what is the oxidation number of sulfur in H2SO4? H2SO4 ದೊಳಗೆ sulfur the oxidation number ಎಷ್ಟಿರ್ತದೆ?
+6 sir.
+6 ಇರ್ತದೆ. ಯಾಕೆ? ಈಗ ನೋಡ್ರಿ H2SO4 ಅಂತ ಬರೆದಾಗ ಇದು +2 ಅದ, ಹೈಡ್ರೋಜನ್ 1 into 2, ಆಮೇಲೆ ಇದು ಆಕ್ಸಿಜನ್ -2 into 4 -8, so it must be +6. +4 to +6 is increase in oxidation number. Increase in oxidation number is oxidation. So it undergoes oxidation, means it is a reducing agent. And sometimes in your textbooks, instead of giving these molecular reactions, they give ionic equations. In ಕೊಡಂಗಿಲ್ಲ, ಹಿಂಗ್ ಕೊಡೋದಿಲ್ಲ. ಏನ್ ಕೊಟ್ಟಿರ್ತಾರೆ? ಬರೇ ಈ ಟೈಪ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಇದೆಲ್ಲ ಕೊಡೋದಿಲ್ಲ. ಹಿಂಗೆ ಏನ್ ಕೊಟ್ಟಾರ ಅಂದ್ರೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನೊಳಗೆ 2Fe+3, 2Fe+2, ಆಮೇಲೆ SO4 -2 ಅಂತ ಬರೆದಿರ್ತಾರೆ, +4H+ ಅಂತ ಇರ್ತದೆ. ಅಯಾನಿಕ್ ಇಕ್ವೇಶನ್. ಮಾಲಿಕ್ಯುಲರ್ ಇಕ್ವೇಶನ್ ಇತ್ತಂದ್ರ ಈಸಿಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡಕ್ಕಾಗ್ತದೆ. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೇಲಿಂದ ಹೇಳ್ಬೇಕಾಗ್ತದೆ. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಆಗ್ಯಾವು, ಗೇನ್ ಆಗ್ಯಾವು ನೋಡ್ಕೊಂಡು ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ನೋಡ್ರಿ ಇಲ್ಲಿ ಏನಾಗದ, ಇದು +6 ಆಯ್ತು, ಇದು +4 ಅಂದ್ರೆ +8 ಆಯ್ತು. ಇಲ್ಲಿ ಎಷ್ಟು ಆಗ್ತದೆ ನೋಡ್ರಿ, +4, ಆಮೇಲೆ ಇಲ್ಲಿ +4, +8, ಆಮೇಲೆ ಇಲ್ಲೇ -2. ಸೊ ಓವರ್ ಆಲ್ ರಿಯಾಕ್ಷನ್ ಒಳಗೆ ಏನೇನ್ ಚೇಂಜಸ್ ಆಗ್ತಾವ ಅಂತ ನೋಡ್ಬೇಕಾಗ್ತೈತಿ. ಈ ಟೈಪ್ ಅಯಾನಿಕ್ ಇಕ್ವೇಶನ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನೊಳಗೆ. ಸೊ ಈ ರಿಯಾಕ್ಷನ್ ನಿಂದ ಏನ್ ಗೊತ್ತಾಗ್ತದೆ ನಮ್ಗೆ? SO2 acts as an oxidizing agent. I take another example. ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೋಣ. MnO4-. What is MnO4-? MnO4- ಅಂದ್ರೆ ಏನ್? ಗೊತ್ತಿಲ್ಲ. KMnO4 ಅಂದ್ರೆ ಏನು?
Potassium
Potassium permanganate.
ಪೊಟ್ಯಾಸಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್.
ಅದು permanganate.
ಇದು ಪೊಟ್ಯಾಸಿಯಂ ಬಿಟ್ಟು ಬಿಡ್ರಲ್ಲ,
Permanganate.
Permanganate.
ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅಯಾನ್ ಅಂತ. KMnO4 ಅಂತಾನು ಬರ್ಕೋಬಹುದು, ಆದ್ರೆ ನಿಮ್ಮ ಬುಕ್ ನೊಳಗೆ ಅಯಾನಿಕ್ ಇಕ್ವೇಶನ್ ಕೊಟ್ಟಲ್ಲ, ಇದೇನಿದು ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಅಯಾನ್. ಓಕೆ, ಸೊ we take the solution of this in water. What is the color of potassium permanganate? Permanganate the color ಯಾವ್ದು ಇರ್ತದೆ?
Reddish orange.
Pink ಇರ್ತದೆ. KMnO4 has pink color. This year you come across in a titration experiment. ಈ ವರ್ಷ potassium permanganate to ferrous ammonium sulfate titration, ಎರಡು titration ಅವ. KMnO4 ಅಂತ ಬರ್ತದೆ, ಪಿಂಕ್ ಕಲರ್ಡ್ ಸೊಲ್ಯೂಷನ್. ಅದನ್ನ ಬ್ಯೂರೇಟ್ ನಾಗ ತಗೊಂಡು ಟೈಟ್ರೇಷನ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಿಸ್ ಹ್ಯಾಸ್ ಪಿಂಕ್ ಕಲರ್. ನೌ ಯು ಪಾಸ್ ಸಲ್ಫರ್ ಡೈಆಕ್ಸೈಡ್ ಇಂಟು ಇಟ್. ಇದ್ರೊಳಗೆ SO2 ಗ್ಯಾಸ್ ಪಾಸ್ ಮಾಡ್ತೀವಿ. ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಸ್ MnO4 minus is converted into Mn+2. So the pink color of KMnO4 or permanganate ion is discharged. Pink color discharge ಆಗಿಬಿಡ್ತದೆ. Plus SO2 is converted into SO4 minus 2. SO4 minus 2 plus H plus ion. MnO4 minus ಪಿಂಕ್ ಕಲರ್ ಇದ್ದದ್ದು ಕಲರ್ಲೆಸ್ ಆಗಿಬಿಡುತ್ತೆ. ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಶೋನ್, ಮಾಡ್ಬೋದು ಇದನ್ನ. ಪೊಟ್ಯಾಸಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಸೊಲ್ಯೂಷನ್ ತಗೊಳ್ಳೋದು, SO2 ಗ್ಯಾಸ್ ಪ್ರಿಪೇರ್ ಮಾಡಿ ಅದ್ರೊಳಗೆ ಪಾಸ್ ಮಾಡಬೇಕು. ಅವಾಗ ಇದರ ಪಿಂಕ್ ಕಲರ್ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿಬಿಡುತ್ತೆ. ಕಲರ್ಲೆಸ್ MnSO4 ಅಂತ ಬಂದಿರ್ತದೆ. ಅಂಡ್ ಇನ್ ಆರ್ಡರ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದಿಸ್ ಇಕ್ವೇಶನ್, ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಲಿಕ್ಕೆ I take 2 MnO4 minus and 2 Mn+2. Okay, and then oxygen and sulfur. Oxygen, sulfur, hydrogen ಎಲ್ಲ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಲ್ಲ. I have to take 2H2O here, 4H plus ion. ಏನೇನು ಬ್ಯಾಲೆನ್ಸ್ ಅದು? Mn is balanced, hydrogens are balanced, but not oxygen and sulfur. Oxygen sulfur balance ಆಗಿಲ್ಲ. ಎಷ್ಟು ಆಕ್ಸಿಜನ್ ಅವ ನೋಡ್ರಿ ಈ ಕಡೆ? 2 4 8 plus 2 10, ಆ ಕಡೆ ಬರೆ 4 ಅವ. ಸ್ವಲ್ಪ ನೆನಪಿಟ್ಕೋಬೇಕಾಗ್ತದೆ ಇಂಥ ಇಕ್ವೇಶನ್ಸ್ ಅನ್ನ ಬರೆದು. ಸೊ ಯು ಮೇಕ್ ಇಟ್ 5SO2 and you will balance it. Here 5SO4 minus 2. ಆಕ್ಸಿಜನ್ಸ್ ಎಷ್ಟಾದು ನೋಡ್ರಿ? 8 plus 2 10 plus 10 20. And this side 5 4 is 20. Okay, so sulfur dioxide reduces the pink color of permanganate ion to colorless manganese ions ಅಥವಾ manganese ions ಅಂತ. ನೋಡೋಣ. So reducing property. Why SO2 acts as a reducing agent? Because it can readily undergo oxidation to sulfur dioxide. It takes nascent oxygen. If it produces nascent oxygen, it is oxidizing agent. If it accepts nascent oxygen, it is reducing agent. It undergoes oxidation. It reduces ferric ion to ferrous ion. It reduces pink colored permanganate ion to colorless manganese ions. Okay, ಬರ್ಕೊಂಡ್ರಿ equations na? Noted? Now, the uses. Uses are generally not asked in your PU board examination, but you must be aware of these things because there can be indirect questions in competitive examinations or giving some clues. Sulfur dioxide, as I told, is having a pungent and suffocating smell. It is used in the manufacture of sulfuric acid. Very important. ಇದನ್ನ sulfuric acid manufacture ನೊಳಗೆ use ಮಾಡ್ತಾರೆ. And also in the manufacture of sulfates like sodium sulfate, calcium sulfate, magnesium sulfate. It is used in the refining of petroleum. Refining of petroleum and sugar. In refining of petroleum and sugar andre enu?
Removal of impurities.
Refining andre purification. ಈಗ metal extraction ಒಳಗೆ ಬಂದಿರ್ತಾವ. Refining of metals means removal of the unwanted impurities present along with the metal, crude metal, not the ore. Ore ಜೊತೆಗಿರೋ impurity remove ಮಾಡೋದಕ್ಕೆ ಏನಂತೀರಿ? ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಥವಾ ಓರ್ ಡ್ರೆಸ್ಸಿಂಗ್ ಅಂತೀವಿ. ಅದಲ್ಲ, ಡಿಫರೆಂಟ್ ಸ್ಟೆಪ್ಸ್ ಹೇಳಿರ್ತಾರ ಅಲ್ಲಿ. ಏನಂತ? ರಿಮೂವಲ್ ಆಫ್ ದ ಅನ್ವಾಂಟೆಡ್ ಇಂಪ್ಯೂರಿಟೀಸ್ ಅಲಾಂಗ್ ವಿತ್ ದ ಓರ್ ಈಸ್ ಕಾಲ್ಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ ಓರ್ or ore dressing. There are several methods of concentration. By hand pricking we can do, by washing or levitation, by froth flotation, isn't it? And now it is a refining of petroleum. Alli refining of metal ant bartav. Conversion of a crude metal into pure metal. There also you come across different methods of refining depending upon the nature of the metal, nature of the impurity. We have methods like liquefaction, vaporization, then zone refining, vapor phase refining, Van Arkel method, Mond's process, electrolytic refining ಅಂತೆಲ್ಲ ಬರ್ತಾವ. So ಇಲ್ಲಿ refining of petroleum and sulfur. ಪೆಟ್ರೋಲು ಮತ್ತು ಸಲ್ಫರ್ ಅಲ್ಲ, ಶುಗರ್ ಮತ್ತು ಪೆಟ್ರೋಲಿಯಂನ ರಿಫೈನಿಂಗ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯಾವ ತರದ ಇಂಪ್ಯೂರಿಟೀಸ್ ರಿಮೂವ್ ಮಾಡ್ತಾರೆ? SO2 ಯೂಸ್ ಮಾಡಿ the basic impurities. If any basic impurities are present along with petroleum and sugar, these are actually neutral. ಇದರೊಳಗೆ ಏನಾರ ಬೇಸಿಕ್ ಇಂಪ್ಯೂರಿಟಿ ಇದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ SO2 ಗ್ಯಾಸ್ ಪಾಸ್ ಮಾಡ್ಬೇಕು. ಒಂದು ಟ್ಯೂಬ್ನೊಳಗೆ ಈ ಸೊಲ್ಯೂಷನ್ ಪೆಟ್ರೋಲ್ನಾಗ ಅಥವಾ ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡು ಅದ್ರೊಳಗೆ ಆ ಟ್ಯೂಬ್ ಡಿಪ್ ಮಾಡಿ SO2 ಗ್ಯಾಸ್ ಪಾಸ್ ಮಾಡ್ಬೇಕು. As SO2 is acidic in nature, it neutralizes the basic impurities present in petroleum and sugar. They get neutralized and settle at the bottom of the tank, and then we can remove the refined petroleum and sugar. Well, depending upon the nature of the impurities, several refinery ಒಳಗೆ ಯೂಸ್ ಮಾಡ್ತಾರ ಅವನ್ನ. Charcoal, activated charcoal is also used in the refining of sugar and petroleum. And there, which impurity is removed? Colored impurity is removed, because the colored impurities are adsorbed on the surface of charcoal. So, ಏನು ಗೊತ್ತಿಟ್ಕೊಳ್ಳೋದು? SO2 is used in the refining of petroleum and sugar. That is to remove the basic impurities. It is used as an anti-chlor and a disinfectant. Anti-chlor means removal of chlorine. Because just now you came across this reaction that SO2 can react with chlorine to form sulfuryl chloride. So it is used as an anti-chlor. And disinfectant. Disinfectant ಅಂದ್ರೆ ಏನು? Destruction of the disease causing organisms. Disinfectant ಅಂದ್ರೆ ಯಾವುದು? ಫಿನೈಲ್ ಇದ್ದಂಗೆ. ಫಿನೈಲ್ ನಿಂದ ವಾಶ್ ಮಾಡಿದ್ರೆ ವಾಶ್ ಮಾಡಿದ್ರೆ ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ಎಲ್ಲ ಡಿಸ್ಟ್ರಾಯ್ ಆಗ್ತಾವಲ್ಲ, ಹಂಗೆ SO2 ಗ್ಯಾಸ್ ಪಾಸ್ ಮಾಡಿದ್ರು the disease causing organisms are killed. It is also used as a bleaching agent for silk and wool. Silk ಮತ್ತು wool ಗೆ bleaching agent ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. SO2 has a bent chain structure like this, just like ozone. Ozone ಇರ್ತದಲ್ಲಿ plus minus, and it's a resonance hybrid of these two. Okay. Yes, the double bond is not fixed. It's like this, minus plus, and actual structure is like this. It has a partial double bond character here. Okay. SO2 has a bent chain structure with a bond angle of 119 degree. Sulfur dioxide ge bent chain structure irutte, ozone gatene. And now we'll deal with the oxo acids of sulfur. So what are oxo acids? Oxo acids of sulfur. Is the time up? Time agad ant kanastade. We will continue the discussion in the next class. H2SO3, H2SO4, H2S2O7, H2S2O6 ಅಂತ ಇರುತ್ತೆ. ಅಂದ್ರೆ 5 ಡೇ ಕೊಡ್ಲಿಕ್ಕೆ S ಡಬಲ್ ಬಾಂಡ್ OH OH ಅಂತ ಇರುತ್ತೆ. This is H2SO3, sulfurous acid. There is a lone pair of electron sulfur here. If I write another double bond O here, it is H2SO4. And both these are dibasic acids because both these hydrogens of the OH group can be replaced. Okay. So, few structures inna ondeರಡು ಅದಾವ. On the next class ನೊಳಗೆ discussion ಮಾಡೋಣ. Okay. See you in the next class. Mohan sir, please end the meeting. ಅವೆಲ್ಲ equations ಇವತ್ತು ಏನು ಹೇಳದ ಬರೆದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ರಿ ಒಂದು ಸ್ವಲ್ಪ.
Yes, sir.
Okay. ಓಕೆ ಬಾಯ್. ಏನೋ ಕಿರಣ್ ತೇಲಿ ಎಷ್ಟು ದಿವಸ ಗಪ್ಪಾಗಿದ್ದಲ್ಲ?
ಮೊಬೈಲ್ ಸಿಕ್ಕಿದಿಲ್ರಿ.
ಈಗ ಬರೋಬ್ಬರಿ ಆಗೈತೆ.
ಹಾ ರೀ.
ಬರೀ ಅಭ್ಯಾಸ ಮಾಡೋದು ಮಾಡೊಂದಿಷ್ಟು. ಓಕೆ, ಈಗ ವಾಟ್ಸಪ್ಗೆ ಹಾಕ್ತೀನಿ ಕೆಲವು ಕ್ವಶನ್ಸ್, ಅದು ಆನ್ಸರ್ಸ್ ಮಾಡಿ ಎಲ್ಲರೂ.
Yes, sir.
ಬಾ.
Yes, sir.